Hello everyone, in this video we will be looking at function overloading and function templates. We will also be seeing as to when to use function overloading and when to use function template. So here is the program, we will just go through it. Here is the declaration of the function integer. It returns integer value. The function name is value of. This is constant. Constant means that this integer value, the value of this integer variable is not getting modified inside the function. Coming to the main, so we have three things. We have integer I, we have double D, and we have string P. Now our objective is to print all these three. So we start off with the integer. We write cout integer value of, and we pass the value of integer I. Now let us see what is the output of this program. We will just run it. G++ overload .cpp -o, which is the output flag. Overload, this is the output name. Let's see what it says. Okay, it has compiled. So / overload. Okay, so it is giving integer 10. Now we have to print the value of double. Okay, so we write double and value of D. Now let us see what the output is. Okay, that's compiled. Okay, now the output is integer 10 double 32, and whereas in the program we see that we have given the double as 32.4. So now we are not getting the required output because we wanted 32.4 and it is giving us 32. So what do we do? Now we will have to overload this function so that it can print double also. Okay, we write double value of pass double. Okay, similarly we just copy the function definition and pass on double and return double. Okay, now let us run run the program. Okay, now we are getting the desired output. Now if you say okay, we want to print the string P also, then again we have to make another function which will be returning a string value of taking a string. Okay, so we write string and here we write P. Okay, here again we copy the data. Okay, now let us run the program. Okay, so we have now got the desired output, but here what we can what we are seeing that there is an unnecessary redundancy being introduced in the code. So if I have to make any changes, like in the if you see the same function is being copied thrice, now if I have to make a change in one of the functions, I have to replicate the change in all of these functions. So what happens is that the code maintenance becomes very difficult. To overcome this, we have the concept of template. In template, what we do is the parameters basically become type independent. So if I have to now templatize this behavior, what I will write is template type name. Now instead of type name we can also type class, but type name is preferable because it reminds us that it is a type. Now what will be the return value? Okay, it is generic, it is t, and what it will take as argument? It will take as argument again t. Now we will remove all this. Okay, coming down, we will remove all this. Now point to note here is that here also we have to write this template keyword type name t. Here the return type is t and the value is again, here we replace the type by t. Here what we have done, you have seen that we have replaced all the types by t. So now let us run this program again. Here I am putting a warning flag. It is a good practice to put this flag on. Okay, now it has compiled successfully. See, we are getting the required output. So now what we have seen is how a function, now what we have seen is the function overloading. First we saw, and then we saw as to how the templates can reduce the redundancy and ease our maintenance of the code. Now the question comes that should we always use templates, or if templates are there, then what is the need of function overloading? Here the typical case was that anything that the body of the function was containing the same code. Now in case the body of the function does not have the same code, there are certain peculiar manipulations which we want in this data which is not same for all the types of parameters, then we will have to go for operator overloading. And that's it. Thank you.